Hey, this is Andrew. I'm going to be going over the sliding filament theory in as simple ways as I can. So, yeah. What is the sliding filament theory? Well, basically, the sliding filament theory is when you contract a muscle and the muscle shortens. So, in this example I so detailedly drew out, I wrote about a bicep contraction because just to keep things simple, it's a pretty simple muscle. So, basically, at the elbow flexion, you can see that the muscle's getting shorter. Obviously, it's not the most detailed, but you get the idea. And if you try it on your own body, you can see your bicep getting shorter as well when you flex your elbow and contract your muscle. Before we dig into this sliding filament theory, I figure we should talk about how a muscle actually contracts and the process that occurs. So you can see in the image on the left that where we are actually looking on a muscle. So this is going to be in the sarcolemma or sarcoplasmic reticulum, pretty much. So an action potential, which is an explosion of electrical activity, traveling towards the axon terminal, which is part of this yellow cell indicated with the red arrow. It's a neurotransmitter. This is the axon terminal is just the bottom of it where those basically that hand looking thing spreads out. So the axon terminal. The electrical activity traveling towards the axon terminal will cause calcium channels to open. Calcium ions diffuse into the cell and triggers vesicles holding acetylcholine to undergo exocytosis to release the neurotransmitter into the synaptic cleft. So we can see the synaptic vessels with the orange arrow coming down and releasing the acetylcholine with the purple arrow into the synaptic cleft, which is synaptic cleft, which is the green arrow. And I meant to mention this before, but the whole process is occurring inside the sarcoplasmic reticulum, which is indicated by the green arrow on the image. Next, acetylcholine binds to the sodium receptor and causes an influx of sodium. The influx makes the muscle excited. This impulse travels down the sarcolemma into the muscle fiber. The impulse that travels down the sarcolemma into the muscle fiber stimulates the sarcoplasmic reticulum, which causes calcium release. The calcium ions diffuse throughout the cell and binds to tropin, which is on actin. We can see the actin on the top right of the screen, top right of the right image. This whole process occurs inside the filaments part of the muscle, as you can see on the image to the left with the black arrow. So if we want to get into tropin and stuff, we're going to need to take a closer look at the actin. So where you see this purple circle, we are going to zoom in pretty much, and now we can see tropin and tropomyosin. So when the calcium ions diffuse throughout the cell and bind to the tropin, a change of shape causes the tropomyosin to move off of the active sites. During this time, a phosphate is released, causing myosin to bind to actin. An ADP is released from myosin, and ATP is added back into the myosin, as you can see on this image. You can see in this image about everything I have gone over so far. And something new. You can see that the myosin heads go up and attach to, well, the actin pretty much. More descriptively, the active sites. They grab onto this and they basically pull the actin closer together during the shortening of the muscle. Like pulling a rope, pretty much. You can see this a little bit better in the image to the right and how they do it. And the H zone would shorten during this process because these myosin heads would extend out, grab the actin, and pull it in closer. And that, in summary, is the sliding filament theory. Thank you.